Good morning, everyone, or good day, everyone, depending where you are in the world. This is Alan Schimmel, and welcome to another webinar from DevOps.com. Today's webinar is sponsored by our friends at IBM, and it is entitled From the Transformation Lab to Production. I think it's going to be a spectacular webinar. If you're not familiar with this kind of stuff, you're really in for a treat. But before we start, I wanted to just go over the ground rules here with you all. As you know, we always try to make time for audience questions, and so we've done it here. I'm hoping we haven't lost our audio. If you look at your GoToWebinar control panel, you will see a questions section, which you can expand. You can ask your questions, type them right in there. Do not wait for the end of the webinar to ask them. Ask them as they pop into your mind. This way you don't have to worry about forgetting them. You could put your questions in there and we can get to them at the appropriate time and queue them. If we couldn't get to all of the questions, we have a record of them and we can ask our panelists to answer them offline if necessary. Now, I see some people are already raising their hand in attendees. I could see you raising your hand, but I really can't. I don't know if you have a question or not, but that raising your hand doesn't get to the questions. You need to ask it in the questions section, which you should all see. If you're having technical issues, perhaps the slides aren't advancing or audio is a problem, please use the chat window or the chat section of your GoToWebinar control panel, and it should be the last one in your control panel. We do have engineers standing by, and they will try to help you solve your problem. So please use that. I see someone's asked their question. They're testing. Yes, it does work, Matthew. Thank you. And let me answer the first question we always get, which is this being recorded and will the slides be available? Answer is yes and yes. We are recording slides, and the recording will be available on DevOps.com as well as our DevOps TV YouTube channel. With that being said, let's get rocking and rolling here because we have two very eager panelists who have a lot to share with you today. As I mentioned before, today's webinar, sponsored by IBM and the IBM Cloud, is From the Transformation Lab to Production. We have two veterans of both the cloud, DevOps, and technology scene with us. First of all, I think this might be his first time on one of our webinars, though he has been on our podcast. We have Mike Kazmarski, IBM Fellow, CTO DevOps, and Service Management, I believe, too, right, Mike?
Yeah, that's right. Thank you, Alan.
Yep. Mike's had a long, distinguished career at IBM and other technology providers, and always had some great stuff to say. So Mike is joining us today. And then joining Mike is a returning guest here on DevOps.com, one of our favorite people, Eric Minnick, IBM Offering Lead, Continuous Delivery, and long time, did I say long time, member of the Urban Code team. Eric, welcome.
Hey, good to be with you. You're one of my favorite people too, Alan.
All righty. All right, guys. With that being said, I'm going to turn things over to you and let you jump right in.
All right, Alan, thank you very much for the nice introduction. I think what we'd like to talk to today is comes from a blog entry that we worked on, or I worked on about a week or two ago, and talked about something called a transformation lab and the use of a transformation lab to drive customers' transformations to digital. So what I'd like to cover today with Eric is, and we'll just kind of converse a little bit on some of these points as we go through these slides, is, what do we mean by a transformation laboratory? What happens in that laboratory? Why a transformation laboratory? What does it look like? What does transformation look like? Particularly from a developer's point of view, but also think about it from an operations point of view and how things are promoted into production and how things don't change all at once. How do they change incrementally? So how do dependencies change? particularly with some of the newer architectures. Where is coordination across the changes, across DevOps technologies and techniques and production and operations? Where is that coordination needed the most? And in spite of the fact that we have a greater need for coordination, and you'll see us talk to that in here as we go through some of the technologies and some of the things that we're seeing with our customers. With all that coordination, how do I bring speed, visibility, and control to the transformation? You know, it sounds simple when we're developing a single microservice and you know, deploying it. But when there's a lot of teams involved and we're going into production and there's concerns, as we'll get to, how do I maintain that speed, visibility, and control? And then finally, what else is impacted by transformation? I'm particularly interested in hearing any questions that anybody has, whether they're asked now or if they're asked later. You know, I'd be glad, and I know Eric will as well, to respond to those questions. So, what do we mean by a transformation library or laboratory? Sorry. To me, a transformation laboratory is a safe place to run experiments to figure things out. So, what do I mean by a safe place? It's an environment, typically in a customer's enterprise, where developers and enterprise architects can dynamically and responsively allocate resources and figure out how they want to evolve their applications, how they want to create new applications. They can access data directly. They're not worried about exposing data and information security in a public cloud environment. And teams can start to understand how to organize around transformed architecture such as microservices. Eric, I think we have an example of that transformation laboratory.
Yeah, no, absolutely. I mean, this is how we see a lot I using our own cloud private offering. They want to start really figuring out, how do I do DevOps well? How do I start working on a microservice architecture using Kubernetes, using Cloud Foundry? How do I bring existing apps into this new world? And so having that kind of a safe space makes a lot of sense. And we're seeing, you know, big adoption of these kind of private cloud plays based on containers, almost always Kubernetes, across the industry. Usually in these teams that have these charters to go find the new way of working, really solidify that. And then the next step is going to be, how do we take that out to the rest of the organization, right? So there is this laboratory aspect, which I really like, that we know we want to do microservices. We think, hey, maybe it's probably Kubernetes. But what's that actually going to be? How do we figure out what the best practices are for our company and our team and drive that through to real success in real applications so that we can then expand it and transform? So that's, I think, something we're seeing quite a lot, Mike.
Thank you, Eric. So another question I get a lot is, you know, why do we have this transformation laboratory? And in general, what we're seeing customers want to do are kind of characterized by the 3 use cases that you see here on this slide. First thing you want to do often is understand which applications they want to invest in terms of refactoring into microservices, bringing to the cloud. That's really use case number 3, or use case, well, it could be all these use cases. Let's start with the use cases in order. They might have existing applications that they can lift directly into a containerized cloud. What would it actually take for me to do that? What changes do I need to make to my code? What services are available in the cloud that I can use? Can I continue to use existing middleware? Can I use existing databases? Will the services I'm dependent on, queuing systems and so on, will they transform into this cloud as well? Or maybe I really want to just leave the application alone and extend it in the second use case by calling public cloud services such as machine learning or business process type of services and just enhance the application, but pretty much leave it without a whole lot of change. Or maybe what I really want to do is create new cloud native applications using microservice architecture, and maybe connect those to existing traditional applications or traditional middleware that I might have. So this is why we think the transformation laboratory is so important, and why we believe from the customers we've talked to that they're looking at, many are experimenting with, have implemented, or rolling out private cloud technology, containerized technology, which really is a nice match for microservices. And doing that next to their traditional applications, next to their traditional middleware, and definitely next to the data that they want to now use in some of the new cloud applications, either that are extensions of their traditional applications or new microservices. What does this look like? Eric, do you want to kind of characterize what this transformation looks like? Hopefully this slide kind of illustrates it a little bit, but I think we've seen all kinds of things going on in this area.
Yeah, and I think those kind of three scenarios you just talked through kind of speak to what it looks like, right? If I'm doing new cloud native applications, all right, then it's a lot simpler, right? It initially looks like, oh, I'm just writing microservices on my new cloud. Cool. And then as it matures a little bit, it starts needing to connect to sources of data or other applications that are already within the enterprise, right? I talk to a lot of enterprises that have, 1,000, 2,000, 3,000 applications, and they're not all getting rewritten in a day, right? So you get a couple new ones, they have to talk to the existing ones in order to do something useful. So if it's brand new, it tends to start, I think, kind of cloud native and then connect over. But if we're kind of platforming, if we're rewriting existing apps, it's not very common to just take the app as it is and sit it on the shelf and go away for a year or two and write something completely new from the ground up. It's much more likely that you're going to rebuild the engine while driving, right? That's what we tend to do in tech. And that's what the strangler pattern, I think that's a term that was coined by Martin Fowler 10, 15 years ago. That's what the strangler pattern is really about, is a consistent way of doing a re-architecture where you start with your existing app, you find some piece that you want to update, you rewrite that piece as a new microservice or whatever new architecture you're moving to, and you connect the existing app to the new piece by replacing what, was a Java call with a REST API call. And so you kind of carve it out chunk by chunk, using load balancers, using API calls within the system in order to refactor it as you're continuing to move that application forward. And I think this is a very realistic situation because it can be very dangerous for a business to just stop development on a mission critical application in order to rewrite it, right? Rewrites are dangerous, right? They tend to be slow to market. And you can find yourself coming out, a year later with something great and on a new platform and easier to update, but you've lost a lot of share in that year. So re-architecting while the thing is still alive and while it's still being enhanced is really the trick. And the strangler pattern is probably the most common way of going about it. I think you're seeing that kind of approach too, right, Mike? Oh, did I lose you there?
Yeah.
Okay, go ahead.
Yeah, the audio dropped out for a second, so I think you're back now.
Okay. Yeah, I don't know what you didn't hear, so hopefully we're doing okay. Yeah, I was just suggesting the strangler pattern is really a common approach we see for people re-architecting. And I think that we've talked about this. That's what you're seeing as well.
Yeah,
right.
Yeah, it certainly is. Another point here is that, as you mentioned, customers are updating their applications, extending their applications, writing new applications, tying them together into, what we call this hybrid application evolution. I think the point is that it's not as simple as PowerPoint. You don't flick a switch and suddenly everybody's running in the cloud and realizing all the dynamic scale and availability and those kinds of capabilities. And as customers start to refactor or write new applications, connect them together in hybrid, they need to run through scenarios and practice how they're going to upgrade and enhance their production environments while they're doing that. So that's another reason for a laboratory is, I need to run this experiment, see if I can upgrade this application, introduce these new microservices on the front end, expose these new APIs, and upgrade and bring it live without any availability hit. Gee, how do I do that? I don't know. Let's run some experiments. We understand the theory. We think we have the automation. But let's make sure that we can really do this before we go and play with it in a production environment. That's another area of experimentation that's going on. It's not just the developing of the code and understanding how to refactor the applications. It's how do I make them operational? How do I automate those operational characteristics? How do I deploy these applications in a way that I can recover or roll back? Or maybe I need to test out scenarios where certain components fail. So that all sounds like experimentation to me. It all sounds like a healthy thing to occur, and it sounds like a healthy thing to occur prior to production to make sure that production does work well. So, Eric, when I think about this, if I think about the latest technologies and microservices and so on, and I read, what is out there, I think, well, if I reorganize around microservices and have these two pizza box squads writing microservices, and they factor it right and they do it right, they should all be pretty much in it. I mean, everything should kind of come into production when it needs to, and so on, right? Is that how you see it working?
Right. No, I just change a line of code, and then that updates the microservice. I test that microservice in isolation, and then I put it in production, and that's all I ever have to do. So I think what's interesting is there's some truth to that, and yet we still tend to deliver large systems, right? And really, we're delivering systems of systems of systems in IT, right? And that the hard part is dependency management hasn't really changed, right? Where we realize our dependencies is shifting a little bit, right? We used to do really fancy things in source control all the time. And then we had more libraries and we did fancier things at build time. And then maybe we had more runtime dependencies and we had more deployment-centric stuff. And that's kind of where we're at now. And maybe it's shifting not towards deployment time, but towards our feature flags and how we coordinate feature flags. But we still have a lot of interrelationships, right? Any given application has multiple squads. Each squad has a lot of microservices it's looking after. And so every microservice talks to a bunch of other microservices and that belong to the squad and don't belong to the squad. And when we want to do real business updates, sometimes we're tweaking an algorithm that can happen in one microservice and that can go out the door 10 minutes later, and that's great. Other times, we really have to coordinate across a bunch of different squads, maybe even multiple applications for this to be real. And I think this is a gotcha that we've seen across the industry where people, I think, see sometimes I can make a small change and put straight into production and read it as, cool, now I don't have to worry about anyone else ever and I can just do my own thing. You've seen people falling into that trap, right, Michael?
Yeah, I sure have. We show here on this diagram squads by color. So the blue squad, is responsible largely, say, for 4 microservices, and the purple squad's, responsible for purple services. Sorry, the squad A is the blue services, squad B is the purple services. I'm color challenged today. And you can see that squad A's microservices interact with squads B's microservices, and that's great as long as the first time they ever create their APIs or the behavior between those interfaces that they get it right. But typically, that takes a little bit of iteration to do too. So even technically, as teams start to pick up microservice orientation, there's going to be some rework. And that rework, might happen after the first set of microservices have gone into production. So how do I handle that rework and coordinating now a new set of microservices that interact in different ways? So, the point is that there's a level of complexity here that I think microservice architectures will address and will make easier over time. But the other characteristic is that now you're functionally decomposing what used to be large monolithic applications into sets of microservices, and there's a lot of them. A large monolithic application could end up being hundreds of microservices, and so you might have tens of teams that you're trying to coordinate in the kind of illustration that I'm showing here. An example of that, I think, Eric, you came up with in our airline example, and something like charging for napkins. Maybe that's something you can kind of walk us through. Not that we're going to start recommending that we charge for napkins in airplanes, but I thought this was a good example that showed how a change could actually permeate across many sets of microservices.
Yeah, I travel a lot, and so the airline industry's habit of adding new things to charge you for comes to mind when I start thinking about relatively simple business changes that have really big technological impact. And so I think this one's kind of interesting. So, we've seen airlines charge you for bags and, to pick your seat and all those sorts of things. So let's pretend the next thing they're going to charge you for is a napkin on the plane or, Kleenex or something. I don't know what the next thing is, but it's something, right? So, to some degree, they're going to have decoupled into microservices, right? If we're going down this path, maybe entirely. But when they make this move, and you think of all the places you experience getting charged for something, that could be the point of sales device that the flight attendant is carrying. You might need to prepay for something, right, on the .com experience. You'll have another opportunity to do that when you check in at the airport kiosk. If you instead walk up to a customer service agent, they've got their own UI, that's their own kind of kiosk. There's probably some intersection with various parts of the rewards program, the loyalty program they have, where maybe you get something free if you're gold status, or if you buy it, you get points. And the point here is that pretty quickly, you can start imagining many different applications that all need to surface the same functionality at the same time, right? One of the questions that's come in already came in from Andy, right? Asking, what about end-to-end testing scenarios? How does that fit in a DevOps world? Well, we need to make sure that if we're going to start charging for napkins, we do that on all of these applications at the same time, right? It's a bad day if you start turning it on in 3 of these applications, but not the other 10, right? Did I end up charging my most loyal members for something I shouldn't have? Did I charge for something that on the plane they have no way of managing, and so they were going to give it up for free anyway, right? We have customer satisfaction issues all over the place on top of being jerks about charging for something extra. So this has to be coordinated. So there's a release management level of coordination to turn it all on at the same time, right? There's a testing scenario to make sure that all of the components work together. There's potentially deployment orchestration if I need to replace one service with a newer service that's got an updated API. If that component isn't ready to have multiple versions live at once. Everywhere we look, we have to do coordination. And the gotcha, bless you, the gotcha here is when we were much more like monoliths, right? When we only had 15 things to manage, 15 applications, we had 15 teams to coordinate, right? Now I might have 150 two pizza box teams to coordinate. And so for these bigger changes, we might actually have a little more work. The flip side is if all we're doing is tweaking an algorithm here or there, then I only have to worry about my two pizza box team. And so that's what's kind of interesting for me is that a lot of the time, the shift to microservices is going to minimize the amount of coordination I have to do. But sometimes when I'm doing big changes, it's going to increase the amount of coordination I have to do. There can be more cats to herd. And so we're making a trade-off, right? To get more agility to do small changes really quickly. But we're still going to have the coordination challenge at the end of the day. And I think it can be dangerous, Mike, for organizations to think, oh, I'm only going to have the small changes going forward, right? I get to ignore these big things because they're going to have a bad day at some point, right?
Yeah. Thank you, Eric. I think this is a wonderful example. And I think it makes a point really well if you think about all the different interfaces that might be affected. Actually, I'll be able to tell how many people actually understood this example the next time I get on an airplane and see who's bringing their own napkins. I think what I'd like to do is, try to characterize situations in which we think the higher level of coordination is needed the most. Things like GitHub and Jenkins pipelines that actually allow microservice teams to very quickly deploy and unit test, if you will, their set of microservices are very important. Those with simple changes, a little coordination, we have a good, well-defined microservice boundary. Services are loosely coupled to APIs. You got them right. Single team impacts, high toleration for failure. And that's what you have in test. Wow, the microservice didn't really work well with this technology behind it. Maybe I need to switch the technology. Or maybe I need to tweak the database behind the microservice. Or maybe I wasn't exposing these parameters correctly. That really works well. And it might work well as teams start to add other microservices. And as they start to become really skilled at 12-factor applications and microservice architectures. But I think the one that you called out is really this complex change and greater coordination example at the bottom. System-wide changes, interactions are coupled. It was the user interface interactions from, the flight attendant was going to actually deal with a napkin purchase or a kiosk in the airport or purchasing ahead of time on the web. Those are all different interfaces, if you will, to being able to purchase for this thing. And so that's a system-wide change. The other thing that I see often is that even though you have teams developing a lot of different microservices, there is a point where they get into a quality assurance environment. Microservices show up in the QA environment, and the system is actually being tested end to end. And in some cases, there might be, or probably are, independent deployments going on as defects are being fixed, so the microservices going into that QA environment. So they're deploying, they're using blue-green deployments, they're using load balancers, they're bringing their new microservice versions up and making sure they run correctly. And now you kind of have a system that you think is stable, and you want to promote that into production. And when you do that, you obviously want to promote those things that have been tested together. You don't want to go back and rerun all of those deployment automations that brought them into the QA environment independently as microservices. You want to take the microservices and what versions they're at and how they're tied to the back-end applications or middleware and promote them to production in exactly the same version configuration as you've determined has been tested. And so that's kind of a controlled deployment in production. That's where you need the governance, the traceability of, and even the access control. You know, many organizations probably wouldn't be too comfortable with squad determining whenever their code was going to go into production, being able to push a button to do that. They'd want a little bit more control over making sure that it was tested well with the other microservices, with the other squads, and that whoever actually is ultimately responsible for the availability of that application once it goes into production has had a chance to say, yeah, I think this is ready to go.
Yeah.
Are there other examples?
No, I think that kind of control and the governance aspect are really key. And in a similar way to how a really rigorous decoupled architecture, which is hard to achieve, right? But if you're really rigorous about that, then for many changes, yeah, you don't need to do big integration tests, right? If you've done a really good job. That earns you the right to go independently. You can do that in a governance model as well with microservices, right? Where you've got extremely good tests. You know, I think the guys from Capital One have talked about what they endeavor to do with, you know, full kind of API level testing, functional testing is appropriate, performance testing, security scans. They have something like 11 or 12 quality checks built into their delivery pipeline. And so if you've done decoupling and you've got rigorous enough quality checks to the degree that anytime you got to the end of that automated flow, a rational person would say, yeah, you're clearly good to go. Plus you've got all the monitoring and run books and safety nets in production that if anything goes wrong, it won't go wrong for very long. Then you can earn the right, to go a little bit faster. But that's a big ask, right? Most organizations, quite frankly, are really bad at testing, or at least fully automated testing. And so to say, yeah, we're going to be fully tested along 10 different metrics at the end of our pipeline every time, and we're just going to go without thinking about it. Yeah. Have you earned that yet? Have you reduced the risk to a degree where an ITIL organization would call that, a normal change, right? So something that, yep, that's the kind of change we do all the time. It's very low risk. We don't need an approval process around it. So you can earn it, but most organizations, quite frankly, don't.
Good point. So, giving all this discussion about complexity, I mean, you know, what's the bottom line here? How do I bring the speed and visibility and control to this transformation? Many of you may have seen these pictures before. We call this two-speed IT, meaning that the traditional systems of record at the bottom are going through continuous integration and application release automation, and they're not containerized or microservicized, if you will. They're largely these monolithic applications, and at the top, seemingly independent pipelines of microservices being driven through DevOps automation into the cloud environment. And I think the key is to really automate across the spectrum for hybrid workloads. There are tools that work well in each environment, but there are certain points where you want to coordinate the automation between these environments. So cloud native meets cloud enabled probably happens when you go into QA or when you promote into production. Those are situations where you want to make sure that essentially you're automating the production promotion, if you will, of the microservices correctly. So there's different techniques for automation that are shown here. And being able to coordinate across those automations, I think, is a very important aspect of bringing the speed, the visibility, and the control to that. Again, if I go back to the laboratory concept. Getting this automation right in working through it in terms of promoting your applications, testing them, looking at the results of testing, understanding what's been tested together, whether it succeeded or failed, and then building automation around whatever process you have to be able to promote that once you've made that determination. Testing out that automation, that's all part of this laboratory as well. So laboratory is for code, it's for proper architecture and building out the microservices, but it's also for developing and testing out the automation and the process that fits your organization for being able to properly with this truly hybrid environment, which I contend many customers are going to have for quite some period of time. Unless they're a startup and just doing, cloud native applications and don't have any backends they need to talk to, they're going to see this picture over and over again. So bringing speed, visibility, and control of transformation is all about automation, but you have to understand the scope of that automation across different tools.
Yeah, no, I
Eric,
think,
do you have any?
yeah, that diagram on the top is how, like, if the top half in isolation is how a lot of people think about their transformation laboratory initially, right? I just got, some simple microservices. I think they're decoupled and okay, this is great. But when we start thinking about, okay, how do we really operationalize this? How do we make this a production service, production application that's real? Then we actually have to pay attention to all of those couplings and relationships that those services have back to everything else that we've got that isn't refactored, that isn't totally decoupled, and really think about, all right, how do we solve this the whole problem, not just, the one that's sitting in the laboratory, right? And I think that's the gotcha, right? Where a lot of people get themselves into trouble is forgetting about, okay, I still have to connect to everything else. How am I going to coordinate with everything else? And we see things like, okay, maybe we're using different bug trackers, right? In maybe it's Git issues or something sitting in our laboratory, and it's a rational team concert or something on the systems of record. Okay, do we have a way of seeing the backlog for the system, right? Knowing when everything's going to be out. So when some executive asks about the feature they want, which requires updating on both sides, can we answer that? What's in a test environment right now that spans the system of record and the new stuff? The more we can decouple with quality APIs between them, it gives you a little bit more separation, but you're still going to have those touch points. You have to figure out how you're going to manage it. And some people do that in spreadsheets and wiki pages. Others go to tooling that's built for it. I'm a tools guy. I like when people pick tools, but you're going to have to manage it one way or the other.
Thanks, Eric. We've talked a lot about putting code into production. There's a few other things that are impacted by transformation. And, I think you've done a really good job just now describing, the automated release across these hybrid environments, the testing, the fact that different tools might be used underneath. The other thing we often see is how monitoring happens. Even in our own cloud, as developers were building out services, they would choose a monitoring tool, and they would use that during development to figure out if their performance is getting better or worse. They would write synthetic response time scripts that would, test the services and test their microservices. But then when they went into production, then they needed to actually change those monitoring feeds, to feed to an operations monitoring tool, something that would give their input in terms of their response time and their availability in the context of all the other services that were using them that are dependent upon them. And so that was part of what also had to be automated, when you went into production. Another aspect was, sometimes things aren't going to run or they need to be scaled manually, or site reliability engineers who might be part of the development team have written some automation that help the operations team around a particular set of microservices or particular services that are being offered. And that also is often deployed as part of the application. That needs to be wired into whatever the management tool is, say an event management tool or whatever that's being used in production. So, the experimentation we're doing in terms of deployment and getting it right in deployment kind of extends, well, it does extend actually, into how do we now integrate dynamically into the operations environment around the applications that we're deploying or promoting into production. I think, Eric, here we have a few products we might mention that provide some of these kinds of capabilities.
Yeah, indeed. This is always the first question in Q&A, and as we move over to the Q&A section here, always just good to talk on this, right? So we've talked about private clouds a lot, mentioned the IBM Cloud Private offering, which has Kubernetes as its base, also offers Cloud Foundry. Really cool private cloud offering there. For continuous delivery, we look at the IBM Urban Code Suite. That's the portfolio I look after. There were a bunch of questions that came in around testing. So we've got a rational test workbench and service virtualization that fits really nicely into this kind of story as well. And then as we kind of shift towards the tools, I guess we're traditionally very much ops-centric, but in a new DevOps world, span across developer and ops kind of personas. We look at the performance management capability to help us figure out where across our new stuff and our old stuff are we hitting bottlenecks, and how do we address that. And then the NetCool suite, which helps us with our network management, run books, and visibility and reporting across our applications and infrastructure. So a lot of good stuff. I don't know if you wanted to touch on anything more there, or if we should just open it up for questions.
Yeah, I guess one other thing I'd add is, with the introduction of IBM Cloud Private, all of the tools that you see listed here, Urban Code and APM and NetCool, obviously support and run in and manage to this private environment, this IBM Cloud Private. And we'll be making that easier and easier over time. But it is an open environment, so you can bring your own tools. I don't want to imply that this is the only way you can do it. This is just the way that we've been doing it. It does support, in addition to containerized middleware, a bunch of containerized open source services, Kafka, Redis, Cassandra, MongoDB, other services that might be used. So I did want to point that out. And I think with that, we've hopefully gone over this topic pretty well, at least at a high level. Maybe we could open this up for questions and see if anybody on the phone has anything they want to ask.
Well, we do have some questions, guys, if you're ready for them. Still got a lot of people raising their hands in the audience. Please type your questions into the question section if you'd like to ask the fellas anything. But let's jump to it if it's okay. You're ready? Actually, before we do, did we want to re-emphasize Think? So, Eric, Mike, help me out here. Think is a new but old conference from IBM this year. It really represents sort of a combination of what was Interop, what was a Watson conference, and others, correct?
Correct.
And it's going to be pretty big. I'm
Yeah,
sorry, Eric.
Yeah, it should be a huge conference. We thought asking you all to come to 6 conferences with us was a little ambitious, and so we wanted to bring everybody together because it all touches on each other, right? We're doing DevOps, we're doing private cloud work to deliver new apps, and a lot of those apps are doing great new analytics. And so to say, no, come to one conference to talk analytics and another to talk DevOps. No, we want to bring it all together cross-pollinate, let everybody see what everyone else is doing, get the best practices. Mike and I are both speaking. We're joined by a ton of customers who are speaking. This is going to be a ton of fun. We're going to learn a lot. Plus, it's in Vegas. That's kind of cool.
Yeah. And I think I'll be there doing videos this year. So that should be, we're going to have a whole little DevOps.com video headquarters set up. And both of you gentlemen are invited to come maybe do a little interviewing. Maybe we can get some of those tons of customers you're talking about, Eric. We'd love to interview them as well.
Yeah, thank you, Alan. You know, it's an opportunity for our customers to meet all three of us who've been here. And also, I wanted to point out, you know, a lot of times, often, this transformation laboratory that we're talking about, it might start out as a private cloud to help customers understand how to build microservices, how to integrate the runtimes in the traditional applications they have and services they have, how to containerize them. But things that are done there are portable into the cloud, the public cloud, a dedicated cloud. And there will be a lot of activity, I think, as well from our cloud division. And you can see how once you've experimented and decided that you want to take advantage of hosting this in the cloud, how that will work as well. So I did want to point that out. We had a tendency to focus on, you know, hey, we have a private cloud here is where you can experiment. But the results of those experiments are often deployed outside of the enterprise. And how to do that and the services that are available will be another thing you can learn about here, I think.
Fantastic. So guys, let's jump into questions though, because I hopefully we'll have enough time to hit all of them, and if not, we'll get them over to you. First question is from Andy, and he wants to know, how is end-to-end testing scenarios handled where multiple microservices are delivered from different teams from a DevOps perspective? Eric or
Well,
Mike?
I think, yeah, I was going to say, I think that's a really good example of where you'd want coordination, something like, say an Urban Code could provide, where you deploy into a QA environment from the test environment, feeds from multiple microservices. So say you've got 5 microservices that make up the application, or 5 sets of microservices that make up the application. You might have a deployment tool that actually deploys those or promotes those, if you will, from their existing test environment in your QA environment. And as part of that promotion, it might automate kicking off the tests that do a system-wide test, if you will, across all those different microservices. Now, I'm assuming that unit testing against the microservices would have occurred, you know, in the test clusters, if you will, for those private clouds. But as you promote a new QA environment, now you have the visibility to a larger part of the system or the whole system, and you want to kick off an automated set of tests, say using some of the rational tools against those, say rational performance tester and so on, as part of that deployment. And actually the last thing could be help you determine whether or not you're actually ready to stage those to production, the things that you have running in QA or not. So it's automating the testing and then automating the driving of the testing functions as part of the deployment in that environment. Eric, I'm sure you've seen more practices on this than I have in the circles you go in. Do you have any other
yeah, I mean, I'll just give a concrete example from an insurer I was working with. They were using some of my tools. They were using, frankly, someone else's private cloud offering. But they had just kind of gone through this transformation. You know, a program with about 200 people, I think 30 of which were testers and used to just all be on a testing team. So they broke that up so that they ended up with 20, 25 of those testers went down into the squads. We're working hand in glove with the developers to make sure that each microservice and collection of microservices belonging to a squad were doing their part well. But the handful of testers kind of held back were the ones who were the deepest subject matter experts and knew what the system was supposed to do really, really well. And they did kind of final integration testing, both automation and manual spot checking to make sure the system was working before the system went to production. right? So from an organizational level, that's kind of how some people are doing it, right? Most of the testers go work in the squads, but you still have integration testing, end-to-end testing, and some subject matter experts are really key for that. So seeing that in insurers, at an airline I was working with, they had people who used to work in the airports kind of come in and be that kind of tester for them. So the end-to-end stuff still happens.
Very good. All right, let's move on to our next question if we can. This is from Keith. How does cloud computing affect my approach to non-functional requirements?
That's a good question. I think it affects what kind of assumptions you're making about the environment that you're running in. I think that cloud computing, and a lot of the reasons that customers want to go to containerized services and microservices, has a tacit, assumption that the infrastructure underneath the cloud is going to fail inherently, and so it provides ways of through services that are already available in the cloud and in most private clouds as well, of replicating what you actually deploy. So if you wanted to automatically have 3 instances of your application running and you want to load balance between them, you don't have to code that in your application as part of the infrastructure that is there. If you want to be able to change out hardware or worry about disaster recovery, the cloud infrastructure, if a node takes a hit, a particular system takes a hit, will automatically move workload around. There are various ways of handling what I'd call stateful sets, that have data attached to them to make sure that the replication occurs, or that the databases are sharded. I think what it really comes down to is that there's non-functional requirements that are kind of inherently implemented by some of the common services, such as auto-scaling, resiliency, and failover, and availability zones, things like that, in the cloud that lift that load off of the application developer having to explicitly code to that. However, that means that they need to, with microservices and with cloud architecture, they need to think about how their applications could use those services, but they don't actually have to replace them. So hopefully it's a little bit of an answer in the right question. If there's a follow-up question to that, please either send me a note or ask it in the chat.
Okay. Our next question is a little bit longer, so I'm going to ask you to both kind of bear with me here. In your experience, how long have you seen a large monolithic application getting converted to microservices? Say one large COBOL application in mainframe with DB2 ZOS as the core database. So I'm not sure what he means by how long have you seen a lot or see a large, or maybe he means how do you see a large monolithic application getting converted to microservices?
Yeah, I think that kind of speaks to the techniques. My favorite answer here is it depends. But we have examples in the IBM Bluemix Garage method of actual customer applications that you can actually go through the example of how they're refactored. We actually have programs that examine the code and suggest ways of refactoring that. I think it's also an economic decision that an organization makes. There's a cost to refactor and run in the cloud versus continue the way you are. There's different operational costs. It depends on how often the application is going to be changed and so on. So there's a lot of factors that come into play. I've seen simple applications actually be done in a few days. I've seen medium type applications be done in months. And of course, if we're talking about a large scale COBOL application with a traditional backend database, that could take years to completely transition, but you may start with the parts that are the most important and start refactoring those and hook them back to what's left of the application. Eric talked about the strangler pattern, and see where that takes you. And if you reach a spot where you want to completely do the whole thing or not. I think it's an ongoing decision based on what you find out, but hopefully that gives you a kind of a rough time frame. Eric, have you seen anything different than that?
No, I think that's right. It can be a couple of days to years, and this idea of figuring out which parts not to change, segregate them off with an API, really powerful. Our colleagues who focus on API management are doing a really good business sitting on top of the mainframe as well, right? Because that's saying, okay, this part is going to stay on the mainframe. It's, maybe that's a performance reason. Maybe it's I just want to leave it there because I don't want to invest in refactoring it. Maybe it's I like everything touched by this to be always encrypted. So I'm just going to have an API on top of that that's REST-based, and I'm going to treat the mainframe as a REST endpoint. Maybe that's the right answer. So yeah, this is where architects make their money, is kind of going app to app and coming up with strategies.
Got it. Okay, next, guys. Do you see merit in moving DevOps tools that are primarily maybe on-prem, say things like Selenium, RTC, RTW, into IBM Cloud Private?
So into, I think, means two different things. It can mean I use those tools against that endpoint, and that makes total sense. Slam dunk, yes. Should I run it from Cloud Private? Maybe. I think in general, kind of a Kubernetes-based approach, a containerized approach, makes a world of sense for a ton of workloads, including tools, is a good fit for where to install. But does it necessarily make sense to bother moving something that's already installed? Maybe, right? You have to do a little business case. I think that's going to be a little less compelling. I don't know, Mike, what do you think on that one?
Yeah, I agree with you that it's going to depend on the customer and what they expend. I will state that, we are coming up with containerized versions of a lot of our middleware, containerized versions of a lot of our management tools, and making those deployable in ICP, and thinking that perhaps once customers have deployed ICP, being IBM Cloud Private, once customers have deployed into a private cloud that is containerized, if they want to install one of our tools, it might be quite easy to do, because those tools are going to naturally take advantage of the non-functional requirements we just talked about that are inherent in the cloud. It might be easier for them to install and manage. And it's really that aspect that we're looking at, of taking our tools and making them available. But I think you'll find with Cloud Private, DB2, MQ, Liberty WebSphere, the data science experience are all examples of existing tools that are normally installed on-prem in their traditional way that are now available in this Cloud Private environment, that all install and upgrade and scale out and fail over consistently. That could actually lower operational costs. So it's really that aspect I would look at as well.
Got it. Guys, we have time for maybe one more question, but I should mention that we probably have at least a half a dozen on here. So we'll send them to both Mike and Eric, and if you can find time in your days to answer these, some of them are pretty good too. Just not
Absolutely.
enough time. Great. Eric, this last one's really up your alley, and you might have mentioned it. Are there existing containerized versions of Urban Code?
Yeah, there's one out on Docker Hub right now that's kind of, a nice way of doing a trial experience. And then the latest fix pack for Urban Code Deploy also provides a lot of what we need for container support. So we'll have kind of official container support here pretty darn shortly. It's probably as much as I can say right now. I also saw a question about deployment targets for Urban Code. What platforms are supported, and that's anything from mainframe to microservices and mobile. So it's all the platforms pretty close, at least the vast majority. So kind of a anything to anywhere kind of play in support of that.
Excellent. Guys, that's going to take us right up to the top of the hour. We will get the rest of these questions from our audience. There, as I said, mentioned some really good questions in here. But Mike and Eric, hey man, guys, thank you so much for a great webinar today. I think the audience was really engaged. I thought there was a lot to learn here, a lot to digest. The slides and the recording of this will be available on DevOps TV on YouTube. That's all one word, DevOps TV, as well as on DevOps.com. You can find it on there. Mike, Eric, we'll see you both at Think in about, probably 2 months now, right?
That's right. Thank you, Alan.
Yes, indeed.
Yep. Think again, everyone, is March 19th to the 22nd at Las Vegas. You can get more information, including registration, at ibm.com/think2018. But for now, hey, that's a wrap on this DevOps.com webinar. This is Alan Schimmel for DevOps.com. Thanks, everyone, and have a great day.